Today we're going to be starting the derivative series. So this is just going to be a 2 or 3 part series that kind of goes over the derivative concepts, the rules of derivatives, and then how to solve different questions or that include derivatives. So this part will consist of the basic topic of derivatives, so what it is, and then just some common rules and examples to go with those rules. The next part will contain more in-depth examples, and we'll get you used to solving derivatives a lot more. So the series is basically for you to get used to solving derivatives and be able to solve them with no trouble at all. So the concept of derivative, what is a derivative? Derivative is essentially the rate of change of f with respect to x, right? So in a function f of x, if you're trying to find the rate of change of f with respect to x, right, that is called the derivative, right? So you're trying to find the derivative. How is a derivative written, right? So a derivative is written either as in this form or in this form, right? So if you see either of these forms, you know that you have to find the derivative. So the question could ask, find the find this, right? So it could just say find that, or it could say find this, right? So in either case, you have to find the derivative. That's how you know to find a derivative. So what is the derivative graphically, right, or geometrically? So let's take this function f of x equals x squared here, right? So as you can see, it's a parabola. Geometrically, the derivative represents the slope of tangent line, right, to the curve of a given point, to the curve of a function at a given point. So in this case, we have our function x squared, and then we're trying to find the derivative of this function, right, at the point x equals 1, right? So what do? Right, we draw a tangent line, right? And the slope of this line, right, the slope of this line that connects to this point 1, right, that connects to this point x equals 1, will give you the derivative of f of x, right? So because the derivative of f of x is 2x, right, the slope of this line is equivalent to 2, right? So let's continue on to some common rules. So the common rules of this function, or of derivatives, sorry, are the first one. There's a couple. So there's power rule, constant multiple rule, sum rule, product rule, quotient rule, and chain rule. So start with power rule. So with power rule, what does that mean? That means that if you have f of x is equal to x to the power of n, right? Then that means that the derivative of f of x, right, will be equal to n times x to the power of n minus 1, right? So it's one of the more simpler rules, right? So let's look at an example. So you have f of x equals x cubed, right? So you have f of x equals x cubed. In this case, if we're comparing this skeletal function to this function, then obviously x is equal to x and n is equal to 3, right? N is equal to 3. So since n is equal to 3, when we're writing our when we're writing our derivative, right, this will be equal to n times x to the power of n minus 1, right? So 3 moves to the front, right? So 3 moves to the front and multiplies, right? And multiplies to the x, right? And then it also is subtracted by 1, right? And then you have your final derivative. So that's your derivative. Now let's say you want to find the derivative of 3x squared, right? That's what we're going to look at next, right? Or that's what we're going to look at in the next two rules. So that's how you apply the power rule, right? And just a quick note, all of these rules for derivatives can be applied in combination with one another, which we will go over in the second part, where we go more in depth with examples and we apply multiple rules to one example. The constant rule. So what is a constant rule? So if you have f of x equals, for example, 5, right? So if you have f of x equals 5, then very simply the derivative of that of 5, or of f of x, is just 0, right? So what does that mean? That means that if the derivative of c, right, if you have a derivative of c, is just equal to 0, right? It's just equal to 0. So if there's no x term, right, if there's no x term, then it's literally just 0. So that's a pretty straightforward rule. Let's move on to the next one. So the constant multiple rule. What does this mean? So if you remember, we said we would kind of dive into it beforehand in the previous two rules. So the first rule, we looked at this derivative 3x squared. So if you want to find the derivative of 3x squared, this is the rule that's going to help you, right? So this is the rule that's going to help you do that. So let's look at what that means. So if you have f of x equals c times g of x, right? What does that mean? We'll go over that in a second. Your derivative of f of x will equal c times g, the derivative of g of x, right? Remember, c is your constant, right? And g of x is your function, right? So let's look at an example. So if you have f of x equals 5x squared, right? So you have 5x squared. If we're comparing it with this form, with the form given, right? 5x squared, 5, right? 5 would just be your c value, and x squared would just be your g of x, right? It would just be your g of x. So when we find the derivative of it, right, this is how it would turn out, right? So you'd have your 5 as your c value, and then you'd have to find the derivative of x squared, right? And then you have to multiply it with 5. What is the derivative of x squared? Remember, we can apply the power rule for this, right? So we take the 2, we move it to the front, right? So that becomes 2 times x to the power of 2 minus 1, right? So this becomes 2x. And then when you multiply 5 times 2x, right, you get 10x. So the derivative of 5x squared is just simply 10x using the constant multiple rule. So if we were to go back here, try to find the derivative of 3x squared, right, then it would just simply be 3 times, right, 3 times 2x, 2 minus 1, right? And this will just give you 6x as your derivative, right? Let's move on to the next one. So the next rule is the sum rule, right? So what is the sum rule? If you have f of x equals g of x plus h of x, then your derivative is the derivative of g of x plus the derivative of h of x. So it's a very straightforward rule. Let's look at an example. So if you have an example of f of x equals x cubed plus 2x to the power of 1, right? Or in other words, just 2x, right? F of 1 of x, so the derivative of f of x, right? So will equal the derivative of g of x, right? So what is the derivative of g of x, right? Remember, if we're using our power rule, the derivative of x cubed is just 3, right? Because the 3 moves to the front. 3 times x to the power of 3 minus 1, right? So that has become, so this entire part, right? So this entire part has become your g1 of x, right? Or in other words, the derivative of g of x, right? And then plus your derivative of h of x, right? So in this case, right, you have 2x, right? So you have 2x. The reason why I've noted this 1 here is because when you find the derivative of this, right, you have to know that the exponent of this x is 1, right? So when you move this, or when you use the the constant multiple rule for this, right, so this is how you're going to do it. This becomes your constant 2, right? So this is just 2 times, right? And then you have the 1 moving to the front, right? And then this will just become x, 1 minus 1, right? And now this will literally just become 2 times 1, and if you know your exponent rules, x to the power of 0, right? X to the power of 0 is equal to 1, right? So this is just times 1, so this is just 2, right? Which is why this becomes 3x plus 2, right? So let's look at the next rule. So we have the product rule next, right? So if f of x equals g of x times h of x, then your derivative of f of x will equal derivative of g of x times h of x plus g of x times derivative of h of x. Now that can sound a little bit confusing, but once we look at an example, it'll be a little bit clearer. Let's move straight to the example. Now we have an example here, f of x equals x cubed times sine x, okay? So we've identified our x cubed as our g of x and our h of x as sine of x, right? So let's see how we can do this. First things first, right? If we're following this notation here, right? If we're following this notation here, the first term in your derivative should be the derivative of g of x times h of x, right? So h of x is left untouched, meaning you have to find the derivative of g of x. So let's find the derivative of g of x. What is the derivative of g of x, right? So you have x cubed, or x cubed, right? What is the derivative of g of x? The derivative of g of x, x cubed, right, should be 3 times x squared, right? Why? Because this is 3 minus 1, right? So this is 3x cubed, right? So let's fix this mistake here. So this should be 3x squared, right? And this should be 3x squared, right? And then again, h of x is left untouched, right? H of x is left untouched. So this part is left untouched and just left to sine x, right? So now you've completed your term. You've completed your term for the derivative of g of x times h of x. So now we're going to try to do our second term, right? So our g of x times our derivative of h of x, right? Now the derivative of sine x is just cos x, right? So derivative of sine x is just cos x, and this would be something that's good to remember. So anytime you're asked to find the derivative of sine x, it will just equal cos x. So in this case, right, again, g of x is left untouched because of the notation, and then here is the derivative of sine x, which is in this case, right, derivative of h of x. Right now we've completed our notation for g of x times the derivative of h of x, right? And that's the product rule. Now let's move on to the quotient rule, right? The quotient rule is similar to the product rule, except now we're dealing with whenever something or f of x is in the form of g of x over h of x, right? Then we're going to have the derivative in this form here, right? So the derivative of g of x times h of x minus g of x times the derivative of h of x over hx squared, right? So similar to the this top part is similar to the product rule. However, if you notice, the sign is different, right? So in the product rule, this was plus. Here, this is subtraction, minus, right? Let's look at an example. So we have our f of x here, x squared over x plus 1. First things first, let's identify what the g of x is and what the h of x is, right? So here, the top is the g of x, right? And the bottom is the h of x, right? Let's move to a derivative and see what we get, right? So first things first, let's try to get this term. So g of x, h of x, right? And again, you know that h of x is left untouched, so you only need to find the derivative of g of x, right? If g of x is x squared, right? So if it's x squared, what rule would we use for this? So here's a question for you: what rule would we use to solve this? if you guessed the power rule, then you are correct, right? So we would use the power rule to solve the derivative for x squared, right? And the 2 goes up in front, so this would be 2, right, times x, 2 minus 1, right? So this would just become 2x, right? And that's become our derivative of g of x, right? And now our h of x stays the same. So now we've completed our first term here, right? Now let's look at our second term. So the next term we have to go is g of x, right? So g of x times the derivative of h of x, right? So let's look at the derivative of h of x, right? So what can we do here? H of x, first of all, right? H of x, first of all, is equal to x plus 1, right? So we have to find the derivative of this. The way we can do this is by using, what do you guys think you can use? If you guess the sum rule, then you're 100% correct, right? So we can use the sum rule here. So x plus 1, right? What is the sum rule? The sum rule is if this is one function and this is 1, then we have to find the derivative of this and the derivative of this, and that will give us the h of x, right? So what's the derivative of x, right? So again, let's see, x is just x to the power 1, right? If we use the power rule here, you can move the 1 to the front, right? You can move the 1 to the front, and this will just be 1 times x to the power of 1 minus 1, right? So this would literally just be 1 times 1, right? So x will just become 1. And then remember we said that whenever you have a constant, right, so a term with no x, right, the derivative is just 0, right? So h of x, right, or sorry, the derivative of h of x is just equal to 1, right? So let's go back here. We have our term now, right? So x squared is left untouched because that's your g of x, right? And then we have a derivative of h of x. And now we have our two terms. And then in the bottom, right, so the denominator is just h of x squared, right? So we know h of x is x plus 1, which is why x plus 1 is just squared. Now here's a bonus question for you guys, and you can comment down below the answer if you did get it. What would be the derivative of x plus 1 squared, right? So this actually ties into the next rule we're going to learn, the chain rule, right? The chain rule, right, so says that f of x, if it equals g of h of x, right, then the derivative of f of x is equivalent to the derivative of g of h of x times the derivative of h of x, right? So let's look at what that means. If we have an example 2x plus 3 cubed, or sorry, 2x plus 1 cubed, right? So 2x plus 1 cubed. What can we do here to kind of solve this, right? First things first, let's look at how to find the derivative for this, right? So the way we find the derivative for this is we have to first take this exponent, right? And similar to the power rule, we multiply to the front, right? We multiply to a front. So the 3 goes to the front here, right? So the 3 goes to the front here. And then again, similar to the power rule, is subtracted by 1, right? Now, what's not similar to the power rule is that you have to multiply this. So this part, right? So this part is your g, right? So that's your that part. However, this part is your derivative of h of x, right? So the h of x is the part that's inside here, right? So what is the derivative, right? What is the derivative of 2x plus 1? Okay, so let's solve it out. Again, this is a combination of multiple rules, right? So you can use the sum rule here, you can use a constant multiple rule, right? So this is a combination of multiple rules. That's all derivatives is, right? It's a combination of all the rules that you learn to solve different questions, right? So let's look at this derivative, right? So you have 2x to the power 1. The 1 can go in front here, times 2x, right? Or let's rewrite this actually. We can write this as, if we consider the constant multiple rule, we can write this as 2c times 1x, 1 minus 1. Right? And again, if we consider this as a c term, the derivative is just 0, right? So this will just become 2 times 1, and we all know x to the power of 0 is just 1, right? Plus 0, so this would just become 2, right? Which is why the derivative of h of x is just 2, right? So chain rule says that whenever you come forward with a question like this, with a question like 2x plus 3 to the power of n, let's just say, you have to do it in this form. First, you have to find the derivative of the entire thing, right? Which is what we did here. Right? And then you have to find the derivative of the inside and then multiply those, right? So when you multiply these, you'll get this answer here, right? So using the chain rule, I want you guys to try to find x plus 1 squared, right? So try to find the derivative, right? So if f of x is equivalent to x plus 1 squared, I want you guys to try to find the derivative of this, right? And comment down below if you guys did manage to get it. And again, as always, follow for more. If you guys have any specific questions, you can always reach out or comment down below. If you guys want any specific topics done or any videos done on any specific topics, please let me know down in the comments, or again, reach out. And if you guys have any tips about the videos, or if there's anything that you would like me to implement, then please, again, comment or reach out. Thank you.